Tell us your name and tell us about your project.
Hi, I'm Dr. Edwin Hubble. I received my PhD in astronomy from the University of Chicago in 1917. I then spent 2 years in the military in World War I as a major in the Army. And then I became a staff scientist at Wilson Observatory in 1919. What I looked at was some fuzzy patches of clouds that were called nebula at the time. There was a great debate that occurred on April 26, 1920, between two astronomers, Shapley and Curtis. They took opposite positions. One that the Milky Way galaxy was the entire universe, and that was Dr. Shapley. And Curtis said, no, there are things that are outside and beyond that of the Milky Way galaxy. So what I do is try to figure out which of them was correct.
What were you trying to do or find?
So again, I was trying to find, were there any objects, figure out a way determine if any object was outside of the Milky Way galaxy, farther away from the Earth than it was. And what I did was, there was a 100-inch Hooker telescope that I used, which was the biggest telescope in the world between 1917 and 1949, to look at the nebula. And I looked at the Andromeda Nebula, and that had been first discovered by Arab astronomers in 964 AD. And within the nebula were these variable stars, big blue stars that would get brighter and dimmer on a very precise time scale, called Cepheid variable stars. And by looking at by knowing the true brightness of the star, I was able to determine how far away the Andromeda strain was, and it indeed was outside of the Milky Way galaxy. And what I was able to do is not only find that there was more than one galaxy, there were actually many galaxies, and eventually the estimate is between 200 billion and 2 trillion galaxies in the observable universe.
Okay, where did the project or experiment occur?
It occurred again at the Mount Wilson Observatory, at the summit of that, where the 100-inch Hooker telescope was located. This is on the San Gabriel mountain chain. It is just above Pasadena in the Los Angeles County. The telescope was at 5,715 feet above sea level, which was good because it was above an inversion layer that kept warm air and smog from coming up to the telescope. So it was one of the most stable air places in the world for astronomy. Unfortunately, Los Angeles since 1919 had an explosion in population. So we had a lot more lights and motor cars and buildings with lights on it. And the light pollution has made it relatively impossible to do any deep space studies there anymore.
What other significant events happened around the world at that time?
Well, this was in the 1920s, because a lot of my work was done between 1923 and 1929. So the Model T Ford was first came off on production. Lindbergh flew across the Atlantic alone. Goddard produced one of the first liquid-fueled aircraft. First TV transmitter was authorized, and the first commercial radio station was in production, was actually on the air. So a lot was going on, a lot of change and a lot of opportunities in the 20s. Unfortunately, in 1929 was the Great Depression, and the stock market crashed, and a lot of people were in poverty for a long time.
Who else was involved in the project?
One person I have to talk about, and I got a picture of her today. It's Henrietta Swan Leavitt. She was at the Harvard Museum, Harvard Observatory, and she, again, because there was a lot of discrimination against women back in those days, she did get her degree in astronomy. However, she was women were not even allowed to touch telescopes at the time, but she was able to touch photographic plates, and she was hired as a computer. I think it was like 3 cents an hour. and she would measure the brightness of the on the photographic plate of stars. What she did is she actually cataloged 1,777 variable stars, published that in 1908, and that she was able to notice that the larger, the brighter variable stars had a larger period, and she actually calculated the linear relationship, or on a logarithmic scale, between luminosity and the period. She was able to determine the actual brightness of a star from that, and I used that as part of my. That was key to my observations of what needed to be done. I had recommended her for. I would have loved her to get a Nobel Prize in astronomy, but unfortunately, she died at the early age of 53 of stomach cancer.
What was your role in the project?
Again, I was a staff astronomer at the Wilson Observatory. This was part of my job, and I was able to pick the nebula to study them, and then I determined, and others determined, that those are not just fuzzy patches, they're galaxies outside of ours.
What impact did your project have on the physics community?
The later work that I had, one of the major impact it had was I started studying the light that came out of the distant stars and looked at the spectra. And I noticed that the spectra had shifted toward the red scale, the long wavelengths in the stars. And the farther away the star was, the deeper the greater the shift was. And by shifting to the red is sort of like the Doppler effect we have in sound, where as an object is coming towards you, it gets a shorter wavelength. As it gets farther and farther away from you, it has a longer wavelength that you detect. And what I was able to determine was that the distance and the speed was a constant. We call it Hubble's constant. And what I was able to determine is that the universe was expanding. And what that means is there was at some point, if you reverse the time, there was some time when the universe was just a single point. And that I was able to determine the Big Bang Theory. That had a tremendous amount of impact on physics, on finding our understanding of black holes, and we're still trying to find out that most of the universe is made up of dark matter and dark energy that we're still trying to find out about. So fairly fascinating.
Of what unity is the science of astronomy to our daily lives on Earth? Oh, God.
Well, astronomy, which is the first science itself, has some of the same. It's trying to answer some of the same questions that medicine is trying to do. How do you image and reconstruct what is something that you can't get to, like a distant star or something inside the body? And a lot of the discoveries and a lot of the instrumentation that was used for astronomy, you'll see that now in MRIs and CAT scans. And you're able to take different scans of a person's body and construct that into a 3D representation of that. There's other stuff, like NASA has a patent on an X-ray machine that's used in sports medicine. There are small stickers that are put on ultraviolet instruments that have to be in a very narrow band of heat, and they heat are used in neonatal care stuff. So again, there's a lot out there.
Okay, thank you for coming back to the dead and having an interview with me.
Thank you, and thank you for doing that. You have a great Navy Marine Corps day.
Thank you, you too.